Good morning, children. Today our topic is to learn about binomial expansion. That is our A2 session, PO4 mathematics. So we are just dealing about this binomial expansion, which is in our A2 level binomial expansion. This we are learning in PO4 A2 level theories. Initially, when you're talking about binomial expansion, I think you can remember if you happen to find any expansion of just like x plus 2 to the power 3 in our AS level, we already use this formula 3c0 x to the power 3 times of 2 to the power 0, and this is 3c1 x to the power 2 and 2 to the power 1, then 3c2 x to the power 1 and 2 to the power 2, and you get 3c3 x to the power 0 for this and 2 to the power 3. This was the binomial expansion where we have already learned in our AS level work. Hopefully, sometimes instead of this 3c0, you just use this format 3c0, and over here you might be familiar with this notation rather than that this. It depends on consents, right? Okay. Then this is 3c3, right? Okay. After that, you just get these figures and you got it, right? But in this case, if you need to find the binomial expansion for this kind of situation, x plus 2 to the power 1 over 3. For this one even, you can write a binomial expansion. But what is the problem where we come across with this one? Let's see if you happen to find here, this is according to this one, 3c0 means if the power is 3, we just put 3 here. So if you get this answer, 1 over 3c0, okay. Just take your calculators and children, see whether include this figure 1 over 3c0 and see whether can you obtain this answer. Obviously, you will realize that you cannot get any figure for 3c0. So therefore, if the power is a fraction, we cannot find for this one. So you can write, cannot say NC0 does not exist for n is a fraction. N is a fraction. Fraction means not an integer type of fraction. So anyway, it's just like a fraction means like 1 over 3, 2 over 3, somewhere like that. Right, okay. Then I'll do another section. That is, if I want to find x plus 2, that is 1 over x plus 2 to the power 3. For this case, you can say this is x plus 2 to the power minus 3. So again, if you use the same format, you will understand that minus 3c0. Just again check whether nc0 whatever nck. I just this is not only nc0, all the figures are not existing, so we cannot just write only not for nc0. So all the nck figures are not there, just like nc1, nc2, nc3. That's 1 over 3c0, 1 over 3c1, 1 over 3c2 does not exist. For this one also, you can say this one also again, if you put it for the negative even, it does not see. So you can say nck does not exist for n is negative. That's other fact where we have to understand. Therefore, for such kind of situations, how we supposed to do a binomial expansion for such question? That is the fact where we need to learn under this binomial expansion in our PO4 mathematics or just our K2 level mathematics. For this case, we use universal binomial expansion. Universal binomial expansion, right? Okay. This universal binomial expansion is valid for fractional powers, negative powers, as well as Instead of this even, you can use this universal binomial expansion. It doesn't make a difference. That is why we call it as a universal binomial expansion. Let's go to the chapter and see whether what do they say. Right. Okay. So this is the fact that we learn. So this is the one what we learn, what we call by universal binomial expansion. Right. Let's see how to find the expression and how to find the facts for universal binomial expansion. Right. Okay. This is the way you can get it. Suppose that the format is like this. It is 1 plus ax to the power n. Later on, we will get the other extensions as well. For the moment, we just write this. If it is so, the expansion become like this. So you can say this is then 1 plus n times of ax over factorial 1. Certain books they mention it's just like nax because the factorial 1 is 1. We know this fact. Then you come up with n minus 1 ax whole thing squared divided by factorial 2. Now, some of you are maybe having a problem that if this is not 1, how do we supposed to find? So there is a technique to find it, nothing to worry. In next part of the lessons, we learn how to find out if this one is not 1. Right, okay. So the next value is n minus 1, n minus 2, ax whole thing to the power 3, divided by factorial 3. So on it goes up to a infinite expression. Now, again, you may be having a problem. If it is infinite, why this term was expressed by into 4 terms? So if it is gone up to infinite, how does it end up with 4 terms? Let's see how to understand that kind of situation even, right? Basically, we'll start with a very simple question and let's try to understand. Suppose that I need to find out 1 plus x. 1 plus x to the power, we will get, initially, I will get into a fact of minus 1, minus 2, I'll get it for the convenience. So we'll write the only, usually when you're writing this for the infinite terms or negative terms, we just write around 3 to 4 terms, right? Okay. So initially start with it. According to this one, what is a? A is 1, what is n? N is minus 2. Now let's start to write it. Right, okay. Then you can say 1 plus minus 2 x divided by factorial 1. Right. Okay, then n minus 1 x squared divided by factorial 2. The next one n minus 1 n minus 2 x to the power 3 over factorial 3. You will write only these terms. That is enough. Okay. Then we can do this expansion. So this is turned up to 1 minus 2x. Over here, if you simplify this, turn up to it's turned up to plus 3x squared. Then over here, 23 6 get cancels with this. It's minus 4x cubed. Minus 4x cubed, like that. You can go ahead with this. That's a way of doing this kind of a question. Right. Let's go to another question and try to make it much sure. The next one I'll get it as 1 plus x to the power half. Okay, so we know that here a is 1, n is half. Right. So you can say 1 plus n is half x over factorial 1. Right. The next one is n minus 1. Half minus 1 is minus half. N minus 1 x squared over factorial 2. Right. Then the next one is n minus 1. Half minus 1 is minus half. N minus 2. Half minus 2 is minus 3 over 2. So you can put it with the calculator and you can obtain this answer if you are not sure about this answer. Okay. Then like that, it can go up to infinity. Right? Okay. Then let's try to simplify this. This is turned up to 1 plus, this is half x. And if you just work out, it's turned up to minus 1 over 8 x squared. So you just divide half into minus half, divide by factorial 2, right? So let's go to the next one. Half into minus half into minus 3 over 2. This answer divided by factorial 6. I think you know how to include factorial 6 into the calculator. Right, okay. So you get the answer half into minus half into minus 3 over 2, that is 3 over 8, divided by factorial 3. Sorry, factorial 3, I just made a mistake. Factorial 3. Answer is 1 over 16 today. Answer is plus 1 over 16 x to the power 3. Right? Like that, it goes up to infinity. Right? Okay. Now let's go ahead with a little bit more advanced question. Right? Okay. Then if it is just like this, 1 over 2x to the power so I just write it as like this 1 over 3. Okay. Then we can understand that this is 1 plus 2x to the power minus 3. I'm using the same format. Now you know that what is a is 2, n is minus 3, right? So we'll start to do this, right? Okay. This is 1 plus n x ax, so it should be 2x over factorial 1. Right. Then n minus 1 squared divided by factorial 2. This is n minus 1, n minus 2, n minus 3 over factorial 3. Right? If you operate this, you will understand that 1 minus 6x, then this is turned up to minus 3 into minus 4 into 2 squared is 4. So it should be turned up to divided by factorial 2. Divided by factorial turn up to 24. So it's turned up to plus 24x. 24x squared, sorry. 24x squared. Then if you come up with minus 3 into minus 4 into minus 5 into 2 squared is 8, 2 cube is 8 divided by factorial 3. It's turned up to minus 8. So the next answer is minus 80x to the power 3. Like that it comes, right? Okay. Now, again, you know how to do this kind of a question. Let's go into another example, right? We'll get 1 over 1 minus 2x to the power 1 over 2. Right? So initially we need to work out 1 minus 2x to the power minus half. It's minus half, right? So over here you can say a is equals to minus 2 and n is equals to minus 1 over 2. Then we can go ahead with this, right? We will work out 1 plus nx. N is minus half minus 2x divided by factorial 1. Then this is n minus 1. Minus half minus 1 is minus 3 over 2. Then minus 2x to the power 2 over factorial 2. Right. So it's done up to n minus 1, n minus 2. So that minus half minus 1 is minus 3 over 2. Minus half minus 2 is minus 5 over 2. So it's done up to minus 2x to the power 3 divided by factorial 3. Okay. Now, if you want, you can go a little bit further. Okay. Let's go ahead with this. Right? Then we need to simplify. Let's go ahead. Let's turn up to 1 half into minus 2. It's 1. Just x divided by factorial 6. Then take your calculator and let's go ahead with it. Minus half into minus 3 over 2 into minus 2 squared. We know that turn up to plus 4 divided by factorial 2. Let's turn up to 3 over 2. Hope you can understand how it came. Plus 3 over 2 x to the power 2. Right. Yeah, that's great. Okay. Then let's go to the next part of it. Minus half into minus 3 over 2 into minus 5 over 2 into minus 2 cube is minus 8. Hope you can understand. Divide by factorial 3. Answer is plus 5 over 2. So this turn up to plus 5 over 2 x to the power 3. So on it goes. That is how you need to do this kind of a situation. Now hope you can understand how to find the expression for this kind of binomial expansion questions. Right. Okay. Then your problem may be if it is how do if since it's universal distribution. Suppose that if I get 1 plus x to the power 3, as I mentioned you before, if this is universal distribution, it's as I mentioned at the beginning of the topic, I told you that it's relevant for this kind of what do you call that integer powers as well. So if you want to do this, it's the same thing. But I may when we writing this by universal expression, it was come up to infinity. But we know that if it is an integer power, it was limited into a certain number of expressions. After that, there is no expressions come across. Like suppose that if it is x plus 2 to the power 3, there should be 4 terms. But this expression goes up to infinity. How does this term, what we call valid for an integer value? Since it's universal, it should be an integer. So it should be a common for all of these fractions. Let's go ahead with this. From the same formula, I'm going to apply that. Okay. Then I just get it as 1 plus n. Over here, a is 1, n is 3. Nx, n is 3, x over factorial 1. Then plus n minus 1, 2 into x squared divided by factorial 2. With the same time, I'm going to write it with it. 1 plus 3x plus 3x squared. Then let's go to the next one. n minus 1, n minus 2, x to the power 3 over factorial 3. So if you do this again, you get the answer x to the power 3, right? Okay, so just simplify and see. Okay. Then you can come up with this n minus 1, n minus 2, n minus 3 is how much? 0, x to the power 4 over factorial 4, right? Okay, then this one, when you're working out with this, answer is 0. That is nothing. Right? Okay, let's go a little bit further and see. 3, 2, 1, 0, minus 1, x to the power 5 over factorial 5. So simply you can understand this one also 0. After that, how much of a term you wrote? Answer becomes 0. So therefore, this answer is valid enough for a integer, positive integer as well. So it's a universal binomial distribution, right? Okay. Now, if you come up with the questions in these examples, so you can say these are the examples they work out. And so these are the some kind of modulations you can see. Yeah, so let's go ahead with this kind of questions. These are the things later on we'll come up with these other extents. Now, if you come across with this kind of questions, you can just obtain the answers by exercise 4a. You can do it, right? Okay. So these are the questions available in exercise 4, right? Then let's go ahead with the little bit extension in this topic, right? Okay. So that is just like this. Suppose that if I want to get this kind of expression, so I will use this one. 1 plus 2x divided by, I will use the expression which I've already used, square root of 1 minus 2x. Square root of 1 minus 2x. Then this one you can say 1 plus 2x divided by 1 minus 2x to the power half. Then you can say this is 1 plus 2x times of 1 minus 2x to the power minus half. Now, no need of working out it in binomial expansion, for this is power 1. Therefore, this is the expression. So you can write 1 plus 2x times of, now you can expand this term. We had this expansion over here. We already get this answer over here. We just do it. That's what I'm using the same expression. So I just little bit make it smaller. Then I can include the same thing over here. Just a little bit further small. Yeah, right. So then I can write it. So this answer is 1 plus x plus 3 over 2x squared plus 5 over 2x to the power 3. Right. Usually we write up to x to the power 3. Then we'll try to do this expansion. Okay. I need a little bit larger expression. So Then I will multiply with 1. Then first of all, I am using some kind of a technique to get this. 1 into 1 is 1. 1 into x is x. 1 into 3 over 2x is 3 over 2x squared. 1 into 5 over 2x cube is 5 over 2x to the power 3. So they can ask, usually they mention, as you mentioned in our AS level, we write including up to x to the power 3, including x to the power 3. They write to the expression, write out the expressions up to x to the power 3, including x to the power 3. Right? That's the expression start. Then this goes a little bit up, yeah, it bit further, but it's ended up with x to the power 3. Now I'll multiply with 2x per 2x into 1 is 2x. So if you want, you can write that term over here, but when you simplify, it's kind of confusing. Therefore, I'll use another technique. 2x into x is 2x squared. Then I write it, sorry, 2x into 1 is 2x. So I write it below this with the same orders. 2x into x is 2x squared. 2x squared. 2x into 3 over 2x is 3x cubed. Then no need of writing the rest of the term because it's ended up with x to the power 3. That is the expression where they expect. Then if you write it, it's turn up to 1 plus, this is 3x. 3 over 2 plus 2 is, we can write 7 over 2 x to the power 2. 5 over 2 plus 3 is 11 over 2 x to the power 3. Like that it goes on. So we can write the answer in this format. That's a way of getting this answer. So like that, if you want to go ahead with little bit advanced questions even, so if you use this kind of situation, if I just get x to the power half divided by this bit. So you might give your question like this. Like this. 1 second. Yeah, they might give a question like this today. 1 plus x over 1 minus 2x, the square root of it. This one you can say 1 plus x to the power half divided by 1 minus 2x to the power half. So this is turned up to 1 plus x to the power half into 1 minus 2x to the power minus half. Right? Then what you need to do is we have to expand these two terms separately. Right? So over here I'm using the initial answers. 1 plus x to the power half. I think we just work out that value. 1 plus x to the power half is this bit. 1 plus half x minus 1 over 8x squared plus. So we just make it a little bit smaller, then we can see, we can include into the other answers as well. Right? 1 plus half x. So this is done up to 1 plus half x minus 1 over 8x squared minus 1 over 8x squared plus 1 over 16x to the power 3. Right? That is the expression for the first part of it. Then I can include this term. Here also they might ask you write down the up to the expression of x to the power 3. Usually that is the format they ask. So this expression, it's over here. So we can write it here. So we can write 1 plus x plus 3 over 2 x to the power 2 plus 5 over 2 x to the power 3. Right? Then we are going to expand it. I'm using the same technique. Initially, I just multiply with 1. 1, I just 1 into 1 is 1 plus x plus 3 over 2 x squared plus 5 over 2 x cubed. Then multiply with half x. Half x into 1 is half x. I'll just write it here. Half x into x is half x squared. Half x squared. Half x into 3 over 2 is 3 over 4. 3 over 4 x cubed. No need of writing further terms, right? Then I'll multiply with x squared. Minus 1 over 8 x squared into 1 is minus 1 over 8 x squared minus 1 over 8 into this is minus 1 over 8 x to the power 3. Then I'll multiply with this plus 1 over 16 x to the power 3. Then simply you can just add these terms together. So simple expression. So you can get it. 1, it's here. 1 plus half is 3 over 2x. Then this is 3 over 2 plus 1 over 2. 3 over 2 plus 1 over 2 minus 1 over 8. 15 over 6. This is turned up to 15 over 6 x to the power 3. Right. Okay. Then you can go ahead with 5 over 2 plus 3 over 4 minus 1 over 8 plus 1 over 16. That is for x to the power 3 terms. It's turned up to 51 over 16. This turn up to 51 over 16 x to the power 3. So this is equal to, I just by mistake just wrote it. So this is would be a final answer. Like that, you can get the expression for any kind of a binomial expansion.